Hey everyone, we're coming up with a new episode on Data Exposed, and this time we are talking about new capabilities of RStudio integration in Azure Databricks. All you R experts and RStudio enthusiasts, you cannot miss this one. Please tune in to watch us for this quick little video in which we demonstrate these capabilities and show you the power of it. Hey everyone, welcome back to another episode of Data Exposed. In this talk, we're going to go ahead and discuss Azure Databricks' new capabilities for RStudio integration. And today, we have in the studios, Yatharth. Why don't you go introduce yourself?
Hi folks, my name is Yatharth Gupta and I'm a product manager on the Azure Databricks team.
Thanks Yatharth for joining us. And of course, I'm Nishant Tucker. I'll be your host for this session. Now, Azure Databricks is really the hottest new analytics product on Azure. Can you tell us a little more about Azure Databricks first, Yatharth?
Absolutely. So what we've been seeing in the analytics market is that Spark is taking off. A lot of our customers, they want to run their big data analytics, machine learning, ETL using Spark. So what we have gone ahead and done is we have built a first-party service, which is a managed version of, what we've gone ahead and done is we've built a managed version of Spark with the founders of Spark. And we call this service Azure Databricks. What this service allows our customers to do is very quickly be able to start from zero and get to their insights. We allow the service to scale up and down automatically. We allow the service to integrate with all the other services in Azure, such as SQL DW, Azure Storage, Cosmos DB, Events Hubs, and IoT Hubs.
Awesome. So now you can come in and leverage the best of open source with Apache Spark and the compliance and security and the ease of use of Microsoft Azure. That's what Azure Databricks brings to the table.
Absolutely, and thank you for pointing out the security part. One of the big things that we have gone ahead and done is, in addition to integrating with other Azure services, we've integrated this with Azure AD. So when enterprises log in, they can use the same common authentication model that they use for every other service to log into Azure Databricks. This has never been done with Spark before.
This is amazing, Yatharth. I'm sure a lot of data engineers and data scientists are taking a lot of advantage of these capabilities inside of Azure Databricks. But today we're here to talk about a specific new capability, the integration of RStudio into Azure Databricks. Now, for people who've been coding with R, they understand that RStudio is like their mecca, their environment of choice for all kinds of machine learning model creation, etc. Now, instead of being kind of narrowed down to a smaller data set in which they've been training their models, they can expand to much larger data sets with Azure Databricks and Spark at their disposal. Tell me a little more about this capability, Yatharth.
So here is how it started. Spark today allows our customers to write code in Python, Java, Scala, and R. And these customers are able to take their code and scale it out to a cluster form factor. What that means is they can take their code and they can run it on many, many machines, which means they can analyze big data sets. One of the feedback that we have received from the R community is they really love their developer tools. RStudio is one such tool. The data scientists in the R community, they live and die by RStudio. And we were making them come to Spark and use a notebook to write R code. So it was time to fix this. What we wanted to do is we wanted to offer them the same convenient environment that they're used to, but at the same time, allow them to leverage the scale of Spark and to be able to run computations 100,000 times faster than they would on their single machine.
This is amazing. So RStudio brings the ease of use of R Studio environments for our familiar users and gives them the scale of execution of compute and processing with hundreds, if not thousands of nodes sitting inside of Azure Databricks with the parallel computing paradigm of Apache Spark.
Exactly.
Well, enough talking. Show us something in action, Yatharth, will you?
All right, so let's look at our Azure Databricks workspace here. So this is your familiar Azure Databricks workspace. This is where a user lands once they create a workspace. And in a workspace, a typical user would go and create notebooks, and they would attach these notebooks to clusters, and their code would run on these clusters.
Absolutely.
So I have gone ahead and created a cluster for you. I call it the RStudio cluster. And when you click on this cluster, you're going to see a new apps tab over here. When you click on this apps tab, you're going to see that RStudio is available on this cluster. All you have to do is go ahead and click this Open RStudio, and you're going to launch into the RStudio UI, which is connected to your Spark cluster. So I have a RStudio project opened up over here, which is connected. I guess it's disconnected. We're going to go ahead and reconnect that. And you can see my project here. This is the RStudio UI. No
Absolutely.
changes. This is the RStudio UI.
Certainly, yes. This looks very familiar for anybody who's been playing around with any kind of machine learning models inside of the R environment. And there are hundreds, thousands of these machine learning experts and data scientists who've been leveraging this environment to create their machine learning models over the past so many years now. And this capability now brings them closer to Spark and the best version of Spark on Azure, that's Azure Databricks.
You're exactly right. One of the things that we learned very quickly is we don't want to make customers do things our way. We want to enable them to do things their way, but help them scale up and scale out. So what we're going to show you here is how you're going to write code in RStudio, and at a point, how you're going to scale that out using Spark. So let's get started. I'm going to use the Diamonds data set. So this is available in Spark in Azure Databricks. So I'm going to go ahead and execute this. So you can see our Diamonds data set. Our goal here today is to use the KNN algorithm to figure out what is the most optimized version of that algorithm to predict price.
Sure.
Okay. So what we do here is we write a function. And I'm going to go ahead and run this function. What this function does is it takes two parameters. It takes the number of neighbors and the number of columns that you're going to use to build this model.
Sure.
So now I'm going to see, so we're going to go here and we're going to create a grid of all of the permutations that are possible. So, the K is going from 1 to 15 here,
yeah.
And we have, I guess we have about 10, 15 columns. So let's go ahead and run this.
Okay.
And you can see that there's 7,665 permutations of these values.
Wow, I see that on the
Right
data
here.
as well as the permutations over there. Of course, yes, I can see all of those 7,665 permutations. And then what I'm most excited about is it has the same interactivity of the RStudio. So it is actually the RStudio because I'm seeing the console over here, I'm executing commands, I'm seeing the results, and now I can see that this is not something different that we've created specifically for Azure Databricks, but it is more like we brought in the familiarity of RStudio and we're just leveraging the power and the use of RStudio, this time with our use cases over here, and then show us how I can leverage the power of Spark as well.
So far, whatever I've shown you, you could have installed RStudio on your desktop and done. Not very hard. You want to use a KNN algorithm, you're using a data set. But now that you have these 7,665 permutations, you want to run them and you want to see what the error rate is on each one of them.
Yeah.
That is something that's incredibly hard to do on a single machine. What ends up happening is RStudio users typically subsample the data set, use a really small data set, and play with that.
Yeah.
And they use really small permutations and try to optimize.
Agree.
We don't want that restriction. We want them to use the large data set and the ability to use Spark to parallelly compute all of this. So I'm going to go ahead and create a Spark session here. So let's see. We go ahead and create a Spark session. And now I'm going to run a grid search, which is essentially running all of these permutations and trying to figure out the errors for each one of them. So the grid search is running. This is, of course, running on 20 nodes. So I have a 20 node cluster. Let me show you that.
Sure. So now we're going back to the Azure Databricks environment where you can show us that the job that we triggered from there actually has some series of computations happening on the cluster now.
Absolutely. So if you look at my cluster, it has 20 nodes.
Yeah.
And if you go and look at the jobs, I'm going to zoom this down. You can see that there are 381 jobs running in parallel, 381 tasks, I should say, running in parallel. Imagine if you had to do this on a single machine. So our cluster is using
20 nodes.
20 nodes. And each of those machines has, we're going to go here and check really quickly. Each of those machines has 20 cores, so that's about 400 cores available. Do you have a desktop that has 400 cores, Nishant?
I can't think of one I ever owned unless I had a data center in my home.
So this is your data center actually in your home. So you are connecting to our data center, leveraging cloud computing and being able to scale this out. So we'll go here, we'll look at what's happening. So there are about 3 more jobs run, 3 more tasks running. Once this completes, the results are serialized and sent back to RStudio. So let me go ahead and go back here. And that's the wrong window. So let me go back here. So it's still running and the data is going to come back here. And you can go ahead in the clusters page, you can look at everything that's happening over here. You can go and look at each of the executors. So that's what's happening on each of the nodes. You can see most of them have finished their work except this one that's still going on. So we're going to wait for this to complete. Oh, I guess there's one more over here.
One more interesting thing that I saw while you were showing us the cluster over here, Yatharth, was that these clusters are serverless clusters, which essentially means that now I can assign this cluster to a team of data scientists rather than dedicating a cluster to one single data scientist or one single practitioner over here. And they can all work against the same serverless cluster and execute their machine learning jobs from RStudio into Azure Databricks. Is my understanding correct?
That is absolutely right. The cluster can be used by one person, the cluster can be used by 100 people at the same time. What we have gone ahead and done, in fact, is we have made sure the cluster scheduling uses an algorithm that prevents you from hogging the entire cluster. So if there's 100 people, we're going to give everybody time to use that cluster.
Absolutely. That's pretty novel from a serverless cluster standpoint. And I'm hoping you understand that how simple we've made it for you to leverage these big data environments and scale out computation processing environments to take your large, massive data processing jobs and make them absolutely seamless in Azure Databricks. And now with RStudio integration, you can also bring in all of your R code and the familiarity from there and implement it within Azure Databricks. Show us some of the results now, Yatharth.
So the results are still coming up.
Okay.
We got aggressive and we used a really large data set.
Nice.
So we're going to give it another 30 seconds or so. As you can see, it's the last task that's remaining over here.
This is fabulous. So I can see that the job has actually taken about 3.25 minutes so far, and it's still executing. So it had about 7,600 plus steps, and out of which just one of the tasks is still pending. Now, all of the others have finished executing, and it's bringing together the results for us to observe over here. Now, tell me a little bit about if I were to execute this job on my desktop as a traditional RStudio user, what would that timeline look like instead of the 4 minutes that I see here?
So the simplest back of the napkin calculation is that look at the number of cores that you have. You probably have 8 cores.
Yeah.
We were using about 400 cores.
Sure.
So, ballpark, that's
50 times the amount of time it would have taken me to get close to the results.
And it's not just that. The other thing that we want to do is we want to make sure that the data scientists who are using RStudio are actually working on production data. So it's faster, but we're also eliminating a step. Because if you were working on your desktop, you would have to take that algorithm, then move it to the cloud, and then run it or train it over there on real data. We've eliminated that step because directly from RStudio, you're skipping that step and using real data.
That is a very important point you make over there, Yatharth. So now instead of executing this and against data that I would have had to pull into my local environment, I am creating the model on a smaller data set, but then pushing the model to execute where my data resides. And Azure Databricks is actually that environment where all of my analytics resides today, because it's amazing. It can bring together all my machine learning, data batch processing, and data stream processing tasks. So I have already got a pipeline written over there, and I already have data residing inside of my storage environments that are kind of computing with the help of Azure Databricks over here.
That's exactly right. And right on cue, our job completed in 5.4 minutes. So let's go and look at what you can do in RStudio with this. So now that you have the results in RStudio, what I'm going to do is I'm going to calculate, what the error rate is.
Sure.
Okay, so I'm going to go ahead and run some calculations here. So it's simple, Control Enter. I'm going to go ahead and plot this data. So you see a plot over here that shows you in 3D what your error rates look like when you have k, which is the number of neighbors you want to use,
Certainly.
and n, which is the number of columns. But this is a little bit confusing. So I'm going to go ahead and clean this up a little bit by removing some of the outliers. So let me go ahead and run this plot again. And now I should get a much more cleaner view. So you can kind of see how this data looks like. We're going to label this data a little bit, so it's a little bit more readable. And all of this is provided in RStudio, so it makes it super simple for you to do this. These interactive graphics, you can explore a lot of things with these. So we're going to go ahead and let's do this one. And
so we're using all the familiar tools of ggplots over there, and then creating functions or leveraging libraries within RStudio itself to get these plots in place.
Absolutely. And now what you can see is we notice some trends. What we notice is the more columns that you have, your error rate is lower. So with one column, your error rate is pretty high. With two columns, it goes down. But at some point, it starts coming back up.
Yeah.
So the answer is somewhere in here.
Okay.
And the other variable that we had was the number of neighbors, k. So you can see with increasing k, the error rate goes down, and at some point, it flattens out. Maybe it starts to come up.
Okay.
So we're going to run a function on this that helps us determine what the optimal values are. So we can see over here that the optimal value of k is 7. So you want to use 7 neighbors. And there are 3 columns that have impact on the predictions. So let's see what those 3 columns are. We're going to go here and figure out those columns. And you can see, to predict the price of a diamond based on the data that we have, carat, color, and clarity make the most impact.
This is amazing. So we came up with a hypothesis. We didn't know what the factors were that were governing the price. We then provided it with some data on pricing and various other features around a specific diamond. We were able to create a certain model around it. We were able to execute that model against a large data set in Azure Databricks. And we were able to bring it together with the help of easy-to-use plots inside of RStudio to observe what the results look like, and then even narrow down on specific columns that are actually governing the price with the most impact on it.
That is absolutely right. I will add 2 more things to that. We just did not use data, we used big data. And we just did not build one model, we built 7,665 models. And that is the power of combining RStudio with Spark on Azure Databricks.
Thank you so much, Yatharth. This was a wonderful introduction to all the integrations that we are bringing with Azure Databricks and RStudio. And I'm sure all of our audience here is actually excited to leverage and put their hands on this particular new capability. Can you tell us how that can happen today?
So all you have to do is, this is available today on Azure Databricks. When you go ahead and create a cluster, you're going to add a library to the cluster, and I'm going to show you how to do that. So you have to enable RStudio. So I'm going to go into my workspace. I am going to find the notebook where I used to enable RStudio. So it's right here. As you can see, I do a lot of demos. Don't mind that. All you have to run is this little script that enables RStudio on the cluster. You give the cluster name. My cluster name is RStudio, and it's enabled.
Wonderful. So just execute one command on the cluster and RStudio becomes enabled. And the step makes sure that RStudio is not enabled if you're not using RStudio. So it's keeping your clusters light and absolutely customized to what you need to execute on them.
Absolutely.
Thank you so much, Yatharth, for guiding us through these new integrations and these new capabilities within Azure Databricks, specifically with RStudio integration. I'm sure our audience members are going to take advantage of this starting right now. Thank you so much for joining us, and until next time.